Okay, when you have the state diagram, moving to state table is rather a mechanical process. So what you have here is you just put there corresponding next states right here in this column. That's it. That's what we do. So for example, if you're at A and you receive 0, you go to A with giving output 0. That's already in the state diagram, right? You just transfer this information into your state table. That's it. This is for our Mealy diagram. So when you're at B, for example, if you have 1, you go to C. If you have 0, you go back to A by giving 0 output. And when you're at C, with 0, you go to D. With 1, you go to C again by giving these outputs. And for D, if you have 1 here, you go to 1 by giving 1. And if you have 0 here, you go to A by giving 0. That's it. That's how you write down your state tables. You just transfer the information. That's it. So this would be your complete state table right here. That's what to do. And for the move, again, you transfer all of this state diagram information into your right here, more model here. But in this sense, you just have your states and outputs. Look, because it's your outputs are not dependent on the inputs. That's it. So when you make state assignments, you have different alternatives. Suppose that you have 2 states. There are only 2 possible combinations here. Your 0 should be A, your 1 should be B, or your 1 should be A and 0 should be B. That's it. 2 assignments are possible. But suppose that you have 4 states, it dramatically increases exponentially. Now you can go ahead and do 24 different state assignments combinations. All of them are possible, but some of them are very popular. The most popular ones are, that's what we will cover. And the first one is counting order assignment. Namely, you write down them like this: 0, 0, 0, 1, 1, 0, and 1, 1. This is called counting order assignment. And the second one, which is I prefer this one much better. So 0, 0, 0, 1, it's gray coding, 1, 0, and 1, 1. This is how we code it. It is called gray coding. And finally, the last one is called the one-hot coding. So this one would be your first state, and this one would be your second state, and this one would be your third state, and this one would be your final state, or something like this. Okay, this is called one-hot coding. For any time, for any state, only one of them would be one particular one. That's it. And we will see how coded state tables right here in this matter. You see, you just replace the A's with this one. This is called the counting order assignment right here. See, we just transfer. We just replace A with 0, 0, and B with 1, 0, and C with 1, B with 0, 1, and C with 1, 0, and D with 1, 1. That's it. That's what we do here. Okay, all right. And this is for gray coding, as I mentioned about you. Okay, you just replace them. That's it. And for both of them, let's see how our flip-flop input and output equations matter here. So for this one, we will try to do a K-map. For this purpose. Now let's do them one by one. All right. Let's try to do this for this counting order assignment to find the flip-flop input next state equations and the output equations. Now this is for counting order, okay? Counting order, and this is our present state, and this is our next state, and this is your output, right? So here for x equals 0 and x equals 1, x equals 0 and x equals 1, you will have these, all right? So your A, B, C, and D are placed like this, and okay, this is where they go. I just fill the corresponding, because where did we get this? We got them from our state diagram, right? It's pretty straightforward. I put them in their positions, 0, 1, and 0, and finally 1. That's it. Now it's obvious that, okay, let's do the design with D flip-flops, because so far we have seen only D flip-flops, right? So these will be your present states. Okay, it would be Y1 and Y2, and these will be your D1. This is one of your flip-flops, and this would be your flip-flop, and your output will be another color. Okay, for D1 and D2 you need to have 𝐚𝐝𝐸. That's it. For D1, okay, I need to have a 𝐚𝐝𝐸, so it should be dependent on x and your current state. And for D2 you need to have another 𝐚𝐝𝐸, which is dependent on x and your current state again. That's it. So for this purpose you write all the combinations here, 0, 1, 0, 0, 0, 1, 1, 0, since it's a 𝐚𝐝𝐸. I'm trying to find the next state input equations. Okay, that's it. And you also, for y, for your output, namely, let's say that this would be your z. Okay, it is dependent on your input and current state again, 0, 0, 1, 1, 0. All right, that's it. So this is all you have, and when you put them in their correct positions, okay, for D1 I will focus on this one, right? I will focus on these columns, but be careful when transferring here for x equals 0. Okay, it will be 0, 0, 1, 0, but be careful about this skip here, because it's not gray coded. So I will write it like this. Okay, 0, 0, 1, 0. Okay, but in gray coding, 0, 0, be careful, 1, 0. And for this one I will write it like this, the blue one, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0. All right, and for the green one I will do the same. Okay, now I focus on these columns right here, and I write them in this order, but be careful about the gray coding here. So I will write 0, 0, 1, 0. Okay, 0, 0, 1, 0. All right, and here you have 1, 0, 0, 1. 1, 0, 0, 1. All right. So I think we already have it. And for the finally the output, you will have 0, 0, 0, 0 and 0, 0, 0, 1. You have this 0, 0, 0, 0 and 0, 0, 0, 1. Okay, for the output, this one. I think the most straightforward one is your z, right? What is your z? That should be x times y1, y2. All right, it's pretty straightforward. And for the blue one, that should be what? Should be this one and this one, right? So it should be y1, y2 not plus x y1 not y2, all right? And for the green one, that should be, for the green one, it should be this one, and this one. I cannot do anything else. And your D2 input will be your x y1 not y2 not plus this one is x, oops, x y1 y2 plus finally this one, it should be x not y1 and y2 not. Okay, perfect. So now you have your input order assignment, flip-flop input equations, and your output equation in counting order assignment. And now let's calculate their cost. Okay, I mean with respect to the counting order assignment cost, I will just calculate gate input cost and gate input cost with nuts. Okay, so it is what is this? It is 2 3 into a 2 input gate, and this is 3 3 3 into a 3 input gate, and this one is, okay, I think 3 inputs, but this one is the same with this one, I guess, so no need to calculate it twice. There are some overlaps, there can be some overlaps, but anyway, okay, so it's 4 7 plus, this one is 7 plus 4, this one is what, 12, right? 12. There are some overlaps, but okay, let's not consider overlaps for now, okay, because you can do multiple level optimization. For this moment, we also count this, I mean 3 2 as well. You don't need to I mean write it like this, so you will have your gate input cost as 22. But of course you can do multiple level optimization on this one to have a reduced cost. Of course you know how to do this. And what about the inverters here? Y1 is inverted, Y2 is inverted, and X is inverted. So gate input cost with NOT is 25. That is about your cost here with the counting order assignment. Okay. Now let's see how it goes with gray coding assignment. Okay, let's now do this for gray coding assignment. So it will be pretty similar. We will repeat the steps, that's it. So, okay, let's say that this is gray coding assignment. And how we do it is pretty similar. You will have your present state and your next state and your output, okay, which is dependent on your x. All right, x equals 0 and x equals 1. That's what you have here. Okay, 0 0. Now your states are coded like this: 0 1. Be careful, 1 1 and 1 0. So here you will have the resulting next states should be 0 0 0 1 and 0 0 1 1 and 1 0 1 1 and 0 0 0 1. So they should be 0, 0, 0, 0, 0, 0, 0, 1. All right. So it looks like this. And the thing is, now you have your A, B, C, D coded like this. That's it. That's the difference. So for this purpose, again, I need to have a D1 flip-flop here and D2 flip-flop here. And these will be your current states, Y1 and Y2. And okay, your output should be Z, let's say. Okay, for each of them, again, I need to have a 𝐚𝐝, Y1, Y2 for D1, 0, 1, 0, 1, 1, 1, 1, 0. Oops. Okay, for D2, I need to have another 𝐚𝐝. It's dependent on your input and your current states. All right, and of course for Y, again, you need to have another 𝐚𝐝 for your inputs and current state. That's it. I think the output is the most straightforward one, so you write here like 0, 0, 0, so it's 0, 0, 0, 1 right here. But be careful, okay, 0, 0, 0, 0, because I write it like this because it is already in gray coding, so I can write them like this. So it should be 0, 0, 0, 1. You're right. So you write it like this, and your Z. Okay, oops, I'm sorry. This one should be Z, right? Your Z equals X, Y1, Y2 not. All right. And your D should be what? I go like this for D, and I go like this, D again. It is 0, 0, 1, 0, 0, 0, 1, 0, because it is counting gray coded already. 0, 1, 1, 0. It's so you make less mistakes in this manner in gray coding. So for this one, all zeros and all ones, all zeros and all ones here. Oops, what is this? Okay, nice. So I will have here this one and this one. Perfect. And for this, I have, look how beautiful they are, right? I think something is on the way that your D1 should be X, Y2 plus it should be Y1, Y2, perfect. And for D2, you will have just X, that's it. So now you need to identify, let's identify our, let's have our, okay, gate input cost with, and gate input cost with nuts here. So that should be for the output, it should be 3. For D2, it's just a cable, that's it. And for this one, it is 2 and 2 into 2. So that should be, okay, into 2 input gate, it should be 6 plus 3, it should be 9, right? And which of them are inverted? Only Y2 is inverted, I guess. Is that right? Yes, I think it's right. Only Y2 is inverted. So gate input cost with nuts should be 10. So this would be your cost if you use gray coding. So as you see, If we use gray coding, our cost is like this. If we use, one hot code counting order assignment, our cost is like this. Okay, and as you see from our let me try to show you the one hot coding here. And if you do a state table like this and one hot coding, your resultant, let's say flip-flop equations, should be like this. And when you calculate the one hot coding assignments gate input cost, it would be intermediate. Like it would be, your gate input cost would be 15 plus your inverters here. And which of them are inverted? Let's see, you say one inverter here and one inverter for X. That's it, I guess. Yes, two. So your gate input cost should be 15 right here, and gate input cost with nuts should be 17, I guess. So it's intermediate. Okay, one hot coding assignment has a cost lower, has a combinational cost, of course, lower than the counting order assignment, but higher than the gray coding assignment. So we can say that combinational cost of gray is less than one hot, less than counting order, counting here for this example. But however, in one hot coding, you need to take into consideration that you have plus two flip-flops here. Okay, you also need to take this into consideration as well, because it is also another type of cost, right? In both of these, you have only two flip-flops right here for counting order and gray coding, but for one hot coding you have four flip-flops. So this is also another cost. Here we're only comparing combinational cost of the circuit. That's it. So finally, your circuit will look like this. If you make the necessary connections and build it, it will look like this. And if you make the necessary technology mapping here to NAND gates, and of course for this parts, this would be your final result. This is your mapped circuit and final result of the circuit. Okay, this is about how to find okay, this is how we of course we don't have the verification part here, but we just discussed from specification we move to formulation. Okay, we do the state diagram, and then we do obtain the state table, then we do the state assignments, rather with one hot coding or gray coding or counting order assignment, whatever. Then we practiced how to determine the flip-flop input and output equations, and that's it. And finally, you need to verify your circuit manually or by computer-aided design tools. So that's it.